So we have something like, we all are familiar with the IPv6 address, and IPv6 address is basically something which is a new kind of technology. We can say it was previously announced in 1999, but now these days we all are relying on IPv6 address as well, and that's the need of the future, we can say. Still, we are also relying on IPv6 address. But we will be starting our NRC recording first with this IPv6 address, because if you are having a good understanding of IPv6 addresses, so it will be very much helpful for you to understand the further topics which we are going to cover up later on. So let's start the discussion with this IPv6, and this is going to be the topic one of your NRC training. So here in this IPv6 address, so we will be starting like with this. So as we all know that this IPv6 is an advanced version of IP address. So we will see that this IPv6 address, we can say it's something the advanced version of IP address. So it was basically released after IPv4 address. So there were two versions of IPv4 address. So we got some IPv4, let's say, and we also got IPv6. So this IPv4 and V6, we know that this V4 is in total of 32 bits and this IPv6 is of 128 bits. Now, this IPv4 address is always written in the form of decimal, whereas this IPv6 is written in the form of hexadecimal. So this is what we got in here about IPv4 and IPv6, that both of these addresses are, and we all know that these are the basic things about the IPv6 and v4. But what is basically the main reason for IPv6? Like, why do we need IPv6 address? So to define the answer, we can say that why we needed this IPv6, why this IPv6 was launched, and what's the use of this v6. So basically, as you can see, that as per IPv4 address, you got 232 bits in total. So if you'll say 2 raised to power 32, so we are going to get around some 4.3 billion addresses. And if you'll say 2 raised to power 128, so in that case, you are going to get some addresses in count of trillions. So basically, right now we are just running off the IPv4 addresses. Many organizations are still relying on this IPv4 address, but the thing in here is that we cannot completely rely on this IPv4 address, because it's having 4.3 billion addresses only. And as per the growing network, as per the rapid growth of a network, and you can see the population is also increasing. So we are actually using a lot of IP addresses, and we do have a lot of gadgets at our homes and at our workspace. So just to support the rapid growth of the networks, we are going to use this IPv6, because this IPv6 is going to give you a very large address space, which just means like you are going to get some trillions of IP addresses. But guys, that before this IPv6, there were two solutions which were created to overcome the exhaustion of IPv4. So we can say two possible solutions were there before IPv6. So what were the two possible solutions? The first was network address translation, and the second one was your subnetting. So both of these possible solutions were just there to make sure we don't run out of IPv4 address, or we can say that just to make sure that the we can say this IP V4 address, we should not get exhaust from this V4 address range, like from this 4.3 billion. So these are the two possible solutions. Because of these solutions, we are still relying on IPv4. But now many operators like Jio and Vodafone are still using IPv6. So this is what we got in here about, just as an introduction to your IPv6 and as in comparison to IPv4. And it's also now pretty much mandatory, guys, for every upcoming operating system in the market which is coming. So it's pretty much mandatory that every device must be having the support of IPv6 address. So it's pretty much mandatory for all the devices to have the feature of IPv6 enabled by default. Now, before going to the advanced things, we'll see some advanced features of IPv6. So we can say IPv6 characteristics. Now, when we talk about the IPv6 characteristics, guys, there are a lot more characteristics, but we'll see. So the first characteristic I always say about the IPv6 address is that we got the large address space. Large address space in the sense I say 2 raised to power 128. I'm going to get a lot of addresses in trillions. Now, as I got the addresses in trillions, you know that every single person can have one IP if we are in having the address in trillions, and we will not run out of this IPv6 address up to 50, 60 years. So this is what we got in here, and we don't need network address translation. So you can say no need of network address translation. We also have no broadcast in here. Then after no broadcasting, we can say like, it supports stateless auto configuration. It supports stateless auto configuration. Now, what is this stateless auto configuration, guys? I'll explain this stateless auto configuration later on in the upcoming videos when we will verify the types of IP addresses. So basically, this stateless auto configuration means that a device can get an IPv6 address by including its own MAC address. So this is what we got in here about the IPv6 characteristics, that it works on stateless auto configuration where an IPv6 address can be like, device can get its own IPv6 address including the own MAC address of that particular specific interface. Also, we got one feature here that we say we got some inbuilt security. Now, when we say inbuilt security, so the first thing come to our mind is IPsec. So it's pretty much inbuilt in the IPv6. And we do have one more thing here, that in IPv6, we have the capability to have multiple interfaces, or we can say multiple, not interfaces, multiple IP addresses per interface. So I'll also explain the same thing when we'll move to the lab session. So the same thing, like just give me a theoretical explanation about this last point, which we have written, that it's having the capability to have multiple IP addresses as per interface, which means, for example, you got router one and this router one has this interface. So let's say you got some IP 10.0.0.1 in here. Now you will select the interface by using the command interface, let's say geg00. Then you will say IP address, and then you will define 10.0.0.1 and slash, let's say 8. So not slash 8 like the default subnet mask 255 and 3 times 0. And then you will say no shut. So manually we define the configurations in IPv4 like this. But in case of IPv4, if you will again select this interface and then you will run the IP address command, and let's say you have written 10.0.0.2. So it's not going to add the secondary address, it's going to overwrite the IP address which you have previously assigned, which was 10.0.0.1. So like in case of IPv6, we have the, we can say it's a feature that over one single interface, we can have multiple IP addresses. So which we will see in the upcoming sessions. So that is what, like, we got some characteristics of IPv6 and some introduction to your IPv6 as of now. Now coming to the next section, like we got some IPv6 structure, like how basically the IPv6 structure looks like, how many bits are there, how many portions are there, like how many octets are there, how many bytes are there. So we'll see each and everything over there. So I'll say IPv6 structure. So this is the heading we got about the IPv6 structure. And over here, let's say I'm going to write one IP address just for an understanding. So let's say I'm going to write some 2001 and I'll say 00 AB, and I'll say again 1234, 1234. Let's say 1234 and again 000 colon, I'll say 000 and I'll say 1234 again. So as you can see that this is how the IPv6 structure looks like. Now we got some things in here to understand about the IPv6, that in total we know it is consist of 128 bits. Now from this 128 bit, guys, we know that we got in total 8 octets. So we can specify this as well. So from 128 bits, we have 8 octets. So as you can see, 8 octets are there, 4 octets, and we got 4 octets here. Now here, guys, see this 2001. So like if separately I'm mentioning this 2001. So this 2001 is basically going to consist in total 16 bits, where like this single 2 here is going to represent 4 bits. So if you'll be converting this to, it will be 8421. So the conversion will be 0010. So like this. So 4 bits here, 4 bits here, 4 bits here, and 4 bits here. So we got in total 16 bits for IPv6. So this is what like basically we have in here, that every octet is having 16 bits, where every single number is going to represent 4 bits. So this is what like the IPv6 structure is all about. Now I'm not talking about these basic things like converting these values and all. So we'll try to see how we are going to make it shorter and what is other structure we have defined here. So when we say IPv6 structure, so in total I told you that there are 8 octets. So from these 8 octets, we have some reservation, like the first 64 bits are considered as your global prefix value, and the next 64 bits are considered as your interface ID. So when I say global prefix value and when I say interface ID, so these first /64 bits are global prefix value, which are same as your network portion and your IPv4 address. And this interface ID is pretty much similar to your host portion, like we have seen in your IPv4 address. So this is what we got in here about the IPv6 structure. So this is what we have in here. And now the next thing is like how you're going to make it shorter. So when it comes to making the IPv6 address shorter, we can make it shorter by, we can say, by reducing the number of zeros in the IPv6 address. So here, as you can see that this IPv6 address we got in here. So in this IPv6 address, if you'll be writing, let's say 2001. So as you can see, we got 0 zeros here, and we got these zeros, and we got these zeros. So I'm not going to write all these entire 440s like this. So instead of that, we can reduce the number of zeros. So I'm not going to use these 2 zeros. I'll simply say AB. And then I got 4 continuous zeros, means 2 octet, third and fourth octet are in 0. So I can use one single 0 like this. The device will automatically understand that here we have left 2 zeros besides this, and like the entire portion is of 0. So that's why we are using it in here. Then I'll say 1, 2, 3, 4. And again I'll use 0, 0 and 1, 2, 3, 4. Now, as this is the shortest IPv6 address, we can say, now again you can make it more shorter, like let's say 2001, you got AB, and now see you got continuous zeros. So instead of writing 2 zeros, you can use double colons like this. So like here we can make these 2 zeros, like these are 2 continuous zeros in here. And you can see we have used 2 double colons. So instead of writing 2 continuous zeros, we can use this double colon, and I'll write 1, 2, 3, 4. And here also you can see that we got 2 zeros. So if you are going to use double colon in here, so it's not correct. So we are not going to use twice the double colon. So we'll say colon 0, colon 0, and again 1, 2, 3, 4. So that's the correct way of writing the IPv6 address. And I'm also mentioning the point that note, never use double colon twice. Never use this double colon twice in one single IP. So this is what we got in this IPv6 structure, which you need to know about, like how we are going to write the IPv6 address. So if in case you are going to get continuous zeros, so you can use double colon, but it's recommended to use the double colon only once in the IP. Never go with the never go 2 times configurations with this kind of thing that can affect your network. And also the device will also get confused in this kind of scenario if you are going with this thing here. Now, the next thing we have about this IPv6 structure, that we got some IPv6 address types. Now in this IPv6 address types, we have something like, we have them, we can say that there are no classes, as like we have seen in the IPv4 addresses, that there were some classes, like there was class A, class B, class D, class C. So we don't have classes in here. So we got 3 categories in this IPv6 address. The first category we got is Unicast. The second category we got is Multicast. And the last we got is your Anycast. Now in the category of Unicast, we got three more categories which we will see. The first we got is global Unicast. The second we got is unique local. And the third one we got is your link local. So these are the three categories of Unicast, whereas this multicast is more similar to D class and Anycast is something we know that. We'll see what exactly this Anycast address is. Now, let's try to understand each and every address types in IPv6 address, and then we'll see some lab scenarios as well. So let's go in here on the next page and let's talk about the Unicast first. So I'm typing IPv6 Unicast. So here in this Unicast, we'll see what are the things we got. So this Unicast got three categories. So we'll see the first category, which is your global Unicast. So this global Unicast, it's nothing but it's more like a public IP. So this is basically we can say more like a public IP where now the question comes is like how you'll identify that this specific IP is a public IP or this IP is a private IP. So for that identification of the IP addresses, we need to like have some ranges, like as in we have class A, B, C with specific ranges. So here also what INA has done. So if you will see that any address starting from 2000, any address starting, any address which is starting from 2000 colon colon slash 3 is identified as global unicast address, which is pretty much similar to your, we can say, public IP. Now, what does this slash 3 here means? This slash 3 means that the first three bits, like I'm writing this point separately, slash 3 represents first three bits are 001 as per INA. And we cannot change this because this is reserved by INA. So now let's try to see how it's the reservation is done. So basically, if you are when I say 2000, see, we got some thing like let's take an example to understand. So let's say we got some 2000 colon colon slash 3. Now this single 2000, we know that it is going to represent 4 bits. So if you are going to convert this 2000 or like simple 2 in case of binary, so 2 in binary will be like 8421. So 2 in binary will be 0010, right? So I'm just erasing this 8421 and I'm writing correctly 2 in binary. It will be 0, 0, 1 and 0. So you can see as per INA, the first three bits are reserved as 001. So this is the reservation which is done by 0. Now there is a situation like you can get a situation like this 001 and there is the last equivalent value as well, which can be 1 as well. So if in case you got this like this will be the 3 in binary. So we say that whenever any address is starting from 2 or 3, any address starting from 2000 or 3000 will be considered as your global unicast address, to which is we can say very much similar to your public IP, which is routable and which cannot be assigned inside the local area networks. So this is what we get in here about this global unicast. Then the second we got is something like unique local. Now we'll see what is the unique local, the second category of unicast. So this unique local is more like private IP. So we can say it's pretty much similar to your private IP address, which we do have in here. Now, as per INA, we have some reservation for this specific category as well. So we got some FC00 colon colon slash 7 or FT. So this is what we got in here, like where the 7 slash 7 means slash 7 values are represented. So any address starting from FC or FT will be considered as unique local. Now, like if you will see the conversions, like let me show you the conversions of FC. So for FC, guys, we know that in case of F and C, F is represented as 15 and C is represented as 12. So if we are going to convert these values, so for conversion of F, 15, so 8421 will be getting F is equals to 1111. And for C, we are going to get its 12, so we'll get 8421. So that means 1100. So the entire conversion of FC will be 1, 2, 3, 4, 5, 6, 7, 8. So you can see 4, 5, 6, 7. So this is the specific reservation here. And in case of FD, you are going to see 1, 1, 1, 1, 1, 1, 0, 1. So this will be the conversion in case of your FD. So that is what we are going to do in case of unique local. So if you'll find any kind of address which is, we can say, starting from FC or FD, so that address will be considered as your unique local address, which is similar to your private IP, which can be assigned inside your local area networks. So that is what we got in this unique local. Then the third category we got in the unicast is link local. Now this link local address is something we can say it's nothing, but it's a default IPv6 address. The default IPv6 address on every IPv6 enabled interface. On every IPv6 enabled interface. So this is what we got in here. Now, if you will see any address starting from FE80 double colon slash and you'll say 10, and the remaining part of this will be the MAC. So I'll verify the same thing to you all when we will see the lab scenario about this link local address. So this is basically like, we don't need to define this link local address on any of the device. So it's by default automatically enabled on all the devices, which we do have in here. So this is what like the three categories of the unicast address, which we have discussed. So like mentioning again, any address starting from FC or FD will be considered as unique local, and any address which is starting with this, we can say 2000 colon colon slash 3 will be global unicast, or 3000, and this link local is by default enabled. We don't need to enable. Now this multicast is nothing but it's more similar to D class. So we'll talk about multicast in here. The second category, this multicast address. So this multicast is something we can say similar to D class. Now, when I say similar to D class, there will be some specific range which is reserved for this multicast. So it always starts with FF00 double colon, and here we got the slash notation as 8. So any address which is starting from FF in case of your IPv6 address, so you need to consider it as a multicast address. Then the last category and the most important part of this IPv6, which is your Anycast address. Now this Anycast address will try to see what exactly this Anycast is. So this address is used to identify multiple interfaces. So we can say used to identify multiple interfaces. Now when we say multiple interfaces, there are many things, but only sends to, or we can say only sends to whichever it finds first. To whichever it finds first. Now let me give you one example for this Anycast address, what exactly this Anycast is. Let's say you are this user sitting in a home environment and you got some internet service connection like from your ISP, and your ISP is connected to various public servers over the internet. You got one server in here, you got server 2, you got server 3, let's say 1, server 2, server number 3. Now let's say now my PC is trying to access google.com. So this PC is trying to access google.com. Now we know that over the internet, if we are trying to access google.com, there is not one single server of Google over the internet. So there are a lot of public servers of Google which are over the internet. So not just a single public server. Now we know that there are multiple servers of Google and they all are connected with each other. Let's assume all these servers are of Google. This server is of Google. And all these three servers are of Google, which are on the public internet. And we know that all these three servers are interconnected with each other. Once they are interconnected with each other, so definitely they are going to maintain a copy of their information. Like all these servers are interconnected, so there will be a copy of all these servers which is maintained together in the devices, like in all these servers. So here in term of server, like, it's a different, we can say it's a different technology when it comes to servers and data centers. So, but see, like whenever we have a group of servers which are acting as one single server, to which we call it as a cluster. So here we are forming a kind of scenario, which is like we can say it's a cluster where we got multiple data centers of Google and all these data centers are connected and this is forming a cluster which is acting as one single server. Now over this cluster, like as a part of infrastructure engineer, what you are going to do is you will assign one virtual IP for redundancy. So this virtual IP which you will be assigning, it will be an Anycast IP. So Anycast means like this user is requesting any service from Google. So to whichever the server it will find first, the server will reply it back to first. So this is what the Anycast concept is. And in Anycast, we can say the global unicast address and the unique local, which we have discussed in the category of unicast. So both of these global unicast and unique local can act as Anycast if you have assigned. So this is what we got in here about the IPv6 type of addresses. So we have seen three types of categories: unicast, multicast, and anycast. Anycast we have already discussed, multicast similar to D class, and unicast we got three categories: global unicast, we got some unique local, and we got some link local. So these are some basic introductory part to your IPv6 addresses. And now in the upcoming video, what I'm going to do is I'm going to create one lab scenario for you all where we will see the configuration of IPv6 addresses, like how the IPv6 addresses are assigned on the devices. We'll try to see some routing labs for IPv6 addresses. So that's all for this video. Now we'll get back in the next video with the lab scenario. And I hope you find this IPv6 information fruitful. So let's connect back in the next video and we'll start with some lab configurations with the assignment of IPv6 addresses over the devices.